So this is going to be a quick pre-teach on the double angle and half angle identities. We're going to do a little bit more in class where we look at how they're derived and look at some proofs for them. But let's just take a sneak peek of what's going on. So here are the double angle identities. If you notice, we have one identity for sine, we have 3 different ones for cosine, and then 1 different one for tangent. These 3 for cosine, you could use any of these 3 for any given situation, but some of them might be easier. Like you might look at what the cosine of theta is and prefer to do that rather than the sine. Maybe for tangent, since they're both the same, you might use this one. So you can use any of these 3 when we're dealing with cosine, but then you have one option for those 2. So looking at a quick example of this, tangent tends to be one of the trickier ones, so let's just go ahead and look at what this looks like. We're going to take the tangent of 2 times pi over 6. So first off, I want to know what the tangent of pi over 6 is, and the tangent of pi over 6 is equal to root 3 over 3. So I'm just going to plug in root 3 over 3 into the formula. So over on this side, just working on the right-hand side, we're going to do 2 times root 3 over 3. So you can tell that's going to be fun in a minute. Then 1 minus root 3 over 3 squared. Notice that I didn't write the tangent again because the tangent of root 3 over 3 is this value. We've already taken care of the tangent part. We don't need to rewrite it. So the next step here on the denominator, we're going to have 1 minus root 3 squared is 3. And don't forget to square both the numerator and the denominator. And we're going to get 2 root 3 over 3 in the numerator. So here's where we are so far. Let me just keep going here. Let's deal with the denominator for a second. 1 minus 3 over 3, we know that this is really 1/3 once you reduce it. So 1 minus 1/3, that's 3/3 minus 1/3. We're going to get 2/3 down here. And we have 2 root 3 over 3 in the numerator. So when I multiply by the reciprocal, I get 2 root 3 over 3 times 3 over 2. Lots of nice stuff cancels out. 2's cancel, 3's cancel, and our final answer here is the square root of 3. And if you had gone back to the original, if we took 2 times pi over 6, that's really pi over 3, and if you looked it up on your unit circle, the tangent of pi over 3 is equal to root 3. So it all checks out. So next one we're going to take a peek at is the half angle identities. Tangent this time has 2 different options. One, they're pretty similar to each other, so it doesn't, you might not switch back and forth, but you could make a choice between these 2. So some things to keep in mind as we're doing these problems. This is going to be important. We're going to take some square roots in the half angle. Remember that there's a positive and a negative version, so you need to remember which quadrant you're in. And what's going to help us is that we have sine. Oops, sorry. Nope. Sorry, we have all sine, tangent, cosine. All students take calculus, so that's going to help us. So if it's sine in the second quadrant, we know it's going to be positive, etc. Also, don't forget that you can split up radicals, and you should take the radicals of them separately. So that means when you take them right here, like the square root of 1 over 9 is really equal to 1/3, because we could take the square root of 1 and the square root of 9. So we have to do both. Or you could also do them separately. So the square root of 2 over 9 is equal to the square root of 2 over 3. So don't forget to break them up. And don't forget to rationalize. Don't forget to rationalize. So let me run through an example of each one of these. I'm going to do it kind of quick because we're going to do some of this work tomorrow. If I want to find the sine, cosine, and tangent of pi over 12, I'm really going to take pi over 6 and take half of that. So we're going to use the half angle identities to solve this. So let's start off with the sine of pi over 12. So that's equal to big square root. So I'm going to plug in pi over 6 into the identity because that's what we're taking half of. So once I solve that, I'm going to find the cosine of pi over 6, which is square root of 3 over 2. And I have to do a little bit of subtraction here. 1 minus the square root of 3 over 2. So that's a little tricky. What we need to do is change this. We're going to do, we're going to take 2 over 2 minus root 3 over 2, so that we get 2 minus root 3 over 2 in the numerator. And I still get 2 in the denominator, which is really a fraction like that. And when I multiply by the reciprocal, we get 2 minus root 3 and all over 4. So that's going to be almost my final answer here. But like I said before, don't forget we can take the square root of what's in the denominator. So the final answer is we keep this, can't really change anything there. Nasty little radical inside a radical, but we can simplify the denominator into 2. So I'm going to do the cosine now, so we're going to take the, fill it into the formula, or the identity. Take a plus or minus. This is all in the first quadrant because pi over 12 is in the first quadrant. So we know it's going to be positive, but we should still include it. 1 plus, this time, the cosine of pi over 6, and we already know what that is, all over 2. So now we have 1 plus root 3 over 2, which is, change that to 2 over 2, so we get 2 plus root 3 over 2, all over 2. Oops, sorry. Let me go back here. Yep, oh, sorry, that was correct. 2 plus root 3 over 2, all over 2. And then we will multiply by the reciprocal and get a almost final answer of 2 plus root 3 over 4, and then take the square root of what's in the denominator, so we get radical and a radical there, kind of gross, but then we can simplify the denominator. So one more example here, we're going to throw in the tangent one. Remember, we have some options. It doesn't really make a big difference here, so I'm just going to fill this in. We're going to take the, we have 1 minus the cosine of pi over 6 all over the sine of pi over 6, which equals 1 minus root 3 over 2 all over 1/2. Don't forget to change that fraction so we can combine them. This time when we multiply by the reciprocal here, I'm going to be multiplying by 2 over 1, which is nice because we get some stuff to cancel out. And so then I'm going to be left with 2 minus root 3 as the final answer there. So hopefully you went back, paused when you needed to, took all the notes that you needed to. Don't forget that when you share your notes with your friends and they're not looking at the same stuff you did, they might not understand everything the same way you did. So do them a favor. Don't share your homework. Encourage them to just sit down and watch it themselves.